Still sleepy? Still audible though, right? So, software supply chain has changed drastically over a period of time, right? Everyone had their NuGet packages now on NPM. So a quick question for everyone in audience right now. How many of you, as executives or as programmers, developers, or technical folks, have written code using AI in the last year? A quick raise of hand, and keep your hand raised if you've written some code using AI, or your team has written some code or maintains some code written by AI. A raise of hand? Someone in that table? No one? Okay. While you're keeping your hand raised, keep your hand raised still if you know exactly which lines they edited, which libraries they incorporated, which packages that modified, and you have trust on all of them as well. Right? Only one hand or two hand I can see. The change from half a room to those two hands indicate where the risk currently exists in this domain. Right? We've gone from tracking SBOMs, which could do some degree of visibility and assurance to us, to being incorporated a machine speed engine that adds new risk at the speed of machine. The entire session today has panelists from financial industry, from lending, from stock market, to asset management, to people who build tools, technologies, and services for them, right? And technology partners who support on that endeavor with cybersecurity solutions and so on and so forth. Trust for this space is not dependent on the speed at which we operate, but the assurance that we can keep our customers' information safe, we can keep their transactions safe, we can operate them within time, which all can break with the risk that we foresee with just the change in hands in this room. So with that in place, right, how is the definition of supply chain evolving in terms of security, right? And what does the rise of AI-generated libraries and package causing on these lines? I'll take it with Abhishek. Abhishek is from Sonatype.
Thank you. So the concept of software supply chain security is evolving. It's no longer just about securing what the developers, engineers are consuming. It's about making sure that whatever the developer, engineers are creating with the use of AI is also secured. In the AI-assisted world of software engineering, we want to be sure that we are able to track every artifact, not just a binary, but every artifact that enters the ecosystem from starting to end. We know where it entered, what commit it was looped in, who created it, when it was created, when was the last patch for it was introduced. That I believe is very important because that will help us a lot with the governance overall framework. Because in today's world, the speed of software development has progressed so rapidly that it is not humanly possible for us to be able to just keep security at the developer end, see what the developer is doing and be happy about it. We need to be able to track all the artifacts that come into the ecosystem, whether they are AI generated or human generated. Especially for the AI generated one, we need to be sure the security compliance also exists for them, because compliance on the security side and licensing side is a very key aspect of software supply chain security, is what my opinion over here is. Back to you, Vinay.
Very well said, Abhishek. And I must say that since the coding part itself has been evolved, the days where coders used to generate the code, write the code, and nowadays there is a AI generated code, AI assisted code. So the coding has been evolved since the evolution is there for the software supply chain as well. Earlier we used to secure only the code libraries, code base, containers, etc. That's it, limited scope. Now, since the AI is there, AI is writing, generating the code functions itself. It's really important to secure the AI bombs as well. So moving from the SBOM to AI bomb, it's a kind of evolution, I would say. It has contributed a lot in this.
Let me just add some quick disclaimer. I think a lot of us comes from regulated industry, and just a quick disclaimer that opinions in the panel are currently of individuals. They do not represent the same posture or same opinion held by the companies themselves. Moving on that, Mohit, you would want to take the same?
Sure, Vinay. Yeah. So, one thing that we need to understand that AI has become the fundamental for our software development. Now, we might have implemented, code checks, code-to-code review, dependency scanning, but will that suffice for our suffice the mitigation of the risk with it? I don't think so. So when an AI model makes a decision, can we track it why? Or can we verify the security with it? So the AI model ships the learned behavior of it, not just the code. So we might see some challenges with the traditional framework, which has been helping us to secure the software supply chain. So what else do we need to do here? Like Gayatri mentioned, from SBOM to AI bomb. So we need to document the model architecture. We need to document the training data sources as well. So what kind of data and databases have been used to train that model? That is very important for us to document, because you cannot secure what you do not know is there in the system. So along with SBOM, it is AI bomb, which can help us secure our software supply chain. Thank you.
Going to Gaurav now. Gaurav comes from FreeCharge. The speed at which things operate there are a bit different than conventional legacy institutions. What do you see in this trend operating on your view?
So, since you mentioned about, in the question that you mentioned about the packages and the libraries, frameworks, that open source libraries, these kind of things. So earlier what used to happen was we used to check the organizations, like they used to check the vulnerabilities and all, and they used to trust, because it was a human generated one. Now, the main focus that has to be, taken care by the organizations is whether it was the framework or the library or the third-party library or the open source framework, whatever we are using as an organization. The first thing, they must get to know about it, like whether it was developed by a human or by an AI. If AI has developed, then which model or which AI has developed in, then whether it was checked or not, like the security or the vulnerability check was there or not, what kind of compliances that has been taken care at the time of development and after that. So these days, since the AI has become part of the contributor in the software development, so now the organizations, I believe that they should not trust only the package and the check vulnerability and move ahead like earlier. They must know the inside of it, like who has developed it and what are the measures that has been taken care of at the time of development and the deployment. So that's the trust factor I think they should take care of.
So taking it to Pranay. Pranay comes with the highest experience benchmark on the panel, right? And has seen it from the ground to current and has very reserved views in terms of how it's moving. How do you feel on this track?
So let's take a real world scenario. Some couple of years back, there was a utility called XZUtil. It is an open source Linux util. Somebody committed. So there was a developer in the open source community. For years he was committing. He also became a moderator of it. And we trust that open source. Linux is supposed to be secure. The gentleman introduced a vulnerability and exploited it. So this is one developer who was a trusted developer over a number of years and with some malified intent changed course. So this is a well documented fact. Now, imagine that problem versus a problem where software is created by AI agents at a massive speed. Every single day, like millions of lines of code around the world is committed to production, or not, at least not in production, but in UAT test environments. Here we knew the person who developed it. In AI, you don't even know who has developed it. So you may say, okay, Claude, Sonnet, fine. But what trained the model? What was the data? What was the prompt? Okay. See, if you ask ChatGPT same question in two different contexts, it will give you two different answers. So the problem is not now just related to, okay, who was the person? Okay. The problem is now what model, what was the data, what was the context, what was the prompt, and that is the scale at which we are looking at this problem now. So definitely it is helping in terms of the speed of development, but at the same time the problems it is going to bring to the fore, which is already bringing, is at a different scale. One more thing that we need to be cognizant about is, obviously it is moving from SBOM to AI-BOM, S plus AI-BOM actually, okay? But you also need that confidence that if I certified something, even whether it be AI, non-AI, I have certified that this is secure and it has good to go for production. Is it the same thing on production? I mean, that's a thing that is the new challenge.
So essentially, we are not just looking at trust of supply chain from external world, but also resilience of delivery pipelines and so on and so forth. In this context, right, every organization has tried to operate a mature cybersecurity practice in context of supply chain and build their own SBOM practices, right? Now, coming from the variety of landscape or the veracity of the industry present here, what does a mature risk scoring, mature update cycle on these SBOM practices, how do they look like today in your organization? I'll start with Badrish.
Sure. So I think before me, panelist has given a much more understanding about the SBOM. So if we go further and see that how we take this as a practice, correct? So as of now, most of the regulators has been mandating that you have to submit your SBOM, basically. So regulatory, so banking, BFSI, they started as a compliance practice. But understand, this is not a compliance to just submit to your regulators, correct? So how I see it, correct? Initially, you might be generating SBOM at a single place. When you are doing a development practices, you are developing a SBOM there. But moving as a secure practices, you have to build a SBOM in every stage of your development cycle, like whether you are building a development build, whether you are building a build on the build pipeline, development and shipping to the production. Because all this environment has a different set of dependency being getting used. So first of point, you must be aware in which environment what you are running there, correct? Second, once you know what you are running there, then it comes to a how do you prioritize the risk, because once any dependency gets highlighted as any CVE, correct? It's become a headache because it's not in a single digit. It's always go to a triple or sometime goes to in the 4 digit, correct? So when you start tackling seeing as a number of CVs I have to fix, it's never going to be happen. So CV can be your first factor to identify whether it's a critical scoring above 9 and 10. Yes, you have to look first, but high and medium you cannot ignore it because it can create a ladder for further exploitation. So what you can do, you can go with the further data which comes from the market, open source, or maybe a paid one, like I normally prefer on the EPSS scores, which give you the visibility whether the CV which you are trying to handle, how it is getting exploited in the wild. So EPSS give you the better understanding. Next cycle, you need to touch upon whatever the solution you are using to identify the CV. You have to ask them, give me a reachability. Give me an understanding that whether it could be exploitable within my environment or not. And the last factor I would try to add it, how critical your resource is, software is or server is. Because you cannot spend $1 million to like secure something which is internally used. So all these factor can help you. Now, AI can be your demon, but AI can be your partner, which actually take all this data in the runtime and let you identify, okay, as an organization, these are the top 10 assets you have to work first on. These are the top 10 CV you have to first work on. So this is how you can start building your mature processes. Ensure it is automated. You does not require a human intervention. Otherwise, you are again going to the loop of time consuming and giving a more efforts there.
So, Badrish, you've added very clear context in terms of how a mature operations operate on, right? I would ask Neeraj, with the speed that your organization operates on, how does it run?
Uh, Good afternoon, everybody, first of all. So, as we all know, SBOM is the first and the most critical part in the entire software supply chain security, right? But how a matured SBOM should look like? So we all talk about SBOM, but SBOM without control is just a piece of paper. So how do you ensure that your SBOM is matured enough to take care of all the security aspects? So of course your SBOM should be updated automatically during any build or any push into production. So first of all, nobody should. Of course, initially you need to maintain it manually. Maybe if you're starting it off, but in the long run, it has to be automatically updated. That is one thing you should take care of. Second, it should be integrated with your vulnerability database. So there should be independent database where you are maintaining all your vulnerabilities which are available right now, available in the market, along with their risk scoring. Then your SBOM should be integrated with your CI/CD pipeline. The moment you push any code, it should go and check if there's any package in my code which is highly vulnerable. Risk scoring you can check, and then you can decide whether you want to really push that into production or not, right? And it has to be continuously. You have to monitor this continuously. So these are some key practices which we should follow when we talk about the SBOM. And of course, with the evolution of AI, it has become more critical now. AI should also be part of your SBOM repository whenever you're going to build this. So yeah, so that's how we are maintaining in our firm. So we are ensuring that it's able to
Essentially,
take
what you're
care of.
advocating is a bill of material context of asset inventory tracking in the new software generation should be agnostic of whether it is AI context based, AI based, hardware based, or software based. Now, coming from practitioners, you Gayatri, you've already seen these kind of challenges being asked by your BFSI customer, right? And a constant producer, publisher, and so on, in this aspect. What's your view and your direction on this?
So talking about the mature practices, along with the basic core one, which has already been mentioned. So to give a quick example or a review, I would say once a package has been added, the SBOM or AI-BOM has to be updated auto. Then we can say the vulnerability score rating, whatever the risk rating has to be done. Post that, that particular package, when it is going to the build, it has to be certain controls, policies in place to authorize it, to approve it. So this is how your SBOM practices should look like. And along with the other practices, the important part I would like to suggest is your practices should include the compliance part as well. Since there are usage of AI where the packages are downloaded instantly, sometimes these packages upgrade themselves, and then the condition for the terms or utilization has been updated. So the compliance is also play a vital role over here.
So in this context, you've added licensing compliance, operational compliance, compliance to ensure key viability of distributing the code further without hampering your own intellectual property that you're building along with it, right? Looking at from the operations of Freecharge, right? How do you add value on this track? What does the mature practice at your end look like, Gaurav?
So, like Badrish also mentioned that the SBOMs are not only for the compliance purposes, right? When you just want to pass the compliance, you are maintaining everything at one place, creating a SBOM, and then once the compliance is passed, then okay, and we'll see in the next time, right? that is something which has to be updated, and you have to keep updating as like he rightly said that if you are developing a software or creating a software, you are creating an SBOM also, right, at the same time. So it what I feel is that the SBOMs should be part of the delivery life cycle only, keeping all the related and required information as part of the SBOMs, so that when you are adding a library or adding a package, you are updating the package, upgrading it, or in few cases you have to downgrade it as well because of compliance and all, because of some other related stuff. So the SBOMs, the best practice that has to be followed and should be followed as it should be part of the delivery cycle. So once the software or once your one release goes on production, it should be one of the checks whether the SBOM has been updated or not. So it's very easy for you from this point, because the size of the softwares these days are very huge, right? So to find out which library we are using, because if you take an example, if compliance is asking there was a vulnerability found, are you using this package or not? Now if your SBOM is not updated, you will have to scan the what library is this library you is using exactly, entire code base. Now the software size, if the software size is huge, it may take 2-3 days, it may take a lot more, it may take 1 day, depending on the size of it, how you search it, how you do it. So I think it should be part of the delivery.
So now we've looked at this, and what key context Gaurav called out is, while you've built and delivered a software today, the components that you've used, the ingredients that you've used, which are documented in the SBOM, may identify an issue later after they've already been released in production, after they've already been deployed at client's edge, within your organization, at your subsidiaries, at your partner organizations, and so on and so forth. So this entire supply chain operates not in terms of just building these SBOMs, but also where organization detects tampering of the software itself, the SBOM itself, and then compromises that can occur based on supply chain risk across the systems, pipelines, and artifacts. So what practices these our organizations are taking, or our industry is taking, in terms of detecting tamper-proofing, compromise prevention, and assurances across these pipelines and life cycles? Badrish, you want to take it up?
Sure. So I'll take up from the tamper-proofing, correct? So we all discussed about the dependency controls which is being used into the application, correct? We need to go further deep there, correct? Deep, I said not inside the source code, but see from where this component has come out, correct? So you might be using open source, you might be using proprietary component as well, correct? So I normally use this statement in terms of trust. It says that, okay, I have built it, I am IBM, or I am XYZ, I have built this, trust me, correct? Instead of I said, don't say me this, say, prove how it is being built, basically. What kind of practices you have followed for building it, correct? So when it comes to the temper protection or integrity, I would say basically, the component which you are using, you should be knowing what material it been used for build, what processes it has been followed to be built. Is your partner organization is actually following the cyber security mechanism or processes as you are doing that, correct? You might be scanning your component day in, day out, and one of your partner who build component internally and open source does not have a knowledge about it, push a vulnerability to your system. So instead of, I would say, it's all about software supply chain, it's all about the trust and knowing what component you are taking in, how those has been built, and who has built that. So
adding more in terms of this trust assurance cycle, right? Gayatri, how do you inculcate that on your supply chain, on your supply cycles?
So once you secure your supply chain, the detection part plays an important role. So to detect the vulnerabilities thereafter, there has to be policy controls in place. As Badrish explained, that there has to be entire overview which is available to you, that what exactly has been utilized, which version, prompts, APIs, binaries, everything. And later on, in case if there is a detection or tampering which you have already detected, I think apart from that, you must have something as a control which plays as a part of resilience. So if something is happening, immediately there has to be a ticket which has to be raised to security, just to give example. And then there has to be a patch which will be fixing up that particular issue.
Mohit, how do you look at it as a trust assurance problem? How do you look at it at speed of resolution problem?
Sure, Vinay. So this basically reminds me of one of the software supply chain attack back in 2020. So most of us assume that the attack might have happened at the source code level, but this wasn't the case. So this time it happened at your build system itself. So the build server got compromised, and so does your artifact and your entire product. So the best practices that I can think of is, you'll have to ensure a chain of trust throughout your system, starting from your source code, from your build server to your target deployment servers. So any framework that can help you, ensure the integrity and authenticity of your artifact, that is something that I think which can secure our product from tampering itself. Apart from this, there could be many other practices. Reproducibility is something that we can do. Generating your build or artifact on one environment, then you might, try to build the same artifact into a different environment and see how exactly it works. That's my point. Yeah.
So we've looked at the entire supply chain on the entry point, but we are also delivering. Right? We're delivering secure containers, APIs, microservices, and that too across various different service providers, data center, cloud services, and so on and so forth. So how do we essentially structure good, secure practices around it? Right? I'll start with Badrish again. Badrish?
Sure. So now environment is mostly people are using is multi-cloud with the attachment of your on-prem environment as well. So nobody is on the single cloud saying that I'm using only X version of it. Something somewhere is on a different cloud, because most come up with their own benefit and disadvantages. But I'll go a step back basically. So when you are going to secure any microservices, any API, any images container side of it, correct? It start with the very simple practices. Only run those services which you required. Start with your image. Suppose you want to run a Linux on that basically, correct? And Linux has 1,000 of services on the base version. Does you require all those services to be run? If not, cut down, have a trim version of that images will be working there. Moving to the pod side of it, Kubernetes side of it. Sometimes I get very shocked. People says that I need to secure my Kubernetes. Kubernetes by standard itself, they give a very clear guideline how you can actually secure complete Kubernetes setups there. There is a clear documentation available. But the challenge is that we start with a very basic networking, saying that, okay, this particular setup I am building in-house, it is internal, you don't require authentication. Why? Means you are saying you are trusting your internal employees, and data says that 90% of attack happens because of them, correct? So the day you start putting hardened control internally, in the future we will putting a focus on the performance side, because that's become your base there, correct? Similar goes with the APIs. Developer builds API day in, day out, correct? For the single functionality. Version 1 comes out, version 2 comes out, version 10 comes out. And then someone do a pen test and say that I have exploited your server because version 1 has a vulnerability. You go back to management, security team says that we fixed 2 years back, but API is still running there. Nobody has seen, nobody has taken a pain to decommission it, correct? So discover, so inventorize your APIs, discover your APIs which is which is being zombied there. See that multiple version of running there. So I would say on all these 3 layers, you have to be best at basics, basically. And this could be replicated in any of the cloud
It does
environment.
sound very clear. We're essentially talking about attack surface reduction. We're talking about operating on a zero or low trust environment. And we're operating on cleaning up legacy so that it does not inculcate further on supply chain risk, right? Sonotype is essentially helping on these tracks, right? Abhishek, you want to jump in on help?
Sure. So when we talk about multi-cloud, multi-deployment strategies from a API perspective over there, like Badrish said, we have to start thinking about security in a different aspect. I want to challenge all of you to take it even one step ahead. Why do we want to do point-in-time security? Why not continuous security? Piece number one. Piece number two, we don't have to think of security from a standalone perspective. The security controls, the security mechanisms need to be standardized across the deployment strategies that we have. It could be multi-cloud, it could be a data center, doesn't matter. At the end of the day, security is not an afterthought. It has to be one of the baselines that is being thought very actively when the architecture is being developed over there. We also need to think it from a perspective of how does security impact when it gets breached. I would love to say everything is 100% secure, but let's be honest, that doesn't happen. Nothing is 100% secure, doesn't matter the amount of effort, cost, innovation comes into place. You are only as secure as much you can do in the ecosystem, but that doesn't mean you cannot have lot of guardrails and plan Bs in place in case security gets breached. Especially in a multi-cloud ecosystem, you need to be very conscious about least privileged access, that even if a particular set of systems get breached, it doesn't impact the larger ecosystem overall. Your larger ecosystem remains intact and the penetrator is not able to go forward over there.
So we've looked at it from the lens of an OEM and we've looked at it from the lens of a practitioner to begin with, right? Mohit, I also want to look at it from a practitioner lens again, looking at it from the context of more preservation and speed retention.
So, when it comes to securing our APIs, our containers, while we are scaling in multiple clouds, this basically highlights, one of the challenge or one of the, balance that every organization is trying to make between scaling and security. So, the question is not whether we can scale. The question comes up whether we can scale securely. So it is very important for us to, keep the security checks at the very initial stages. When it comes for the containers, can we harden the images? Can we do the shift left security? Can we run everything with least privileges? Now, when it comes with the APIs or the microservices, do we have the proper encryption in place? Do we have some proper authentication in place? Yeah.
Looking it from Gaurav's lens, right? Gaurav, how do we look at that across already deployed infrastructure, right?
So basically, like you said, that already deployed infrastructure, and if you think from the scale point of view, now organizations are, the softwares are running hundreds of containers, thousands of APIs we're running, and at that point of time, at that scale, there are several microservices that we are using, that we have implemented, and we are as an organization, it is there in the production. Now, making sure that they are all secure, I would say the 3 points that I would try to cover in. So first is having a clear and strong documentation of what is there on the production, what is running currently, how many containers are there, what is the list of APIs are there, which microservices are currently enabled, or they are, they are in the production, they are in a running stage, because you cannot secure what you don't know. Second, I would say, second would be zero trust policy. Zero trust policy means you should not trust anyone, whether it is a team member, whether it is a server, whether, because in the multi-cloud systems, there are the APIs are communicating with each other, or the microservices are communicating with each other. So before the communication starts or before anything happens, they will have to identify themselves first, that who are they or who they want to communicate with. And the third is automation, I would say. Automatically scanning the containers or the APIs, vulnerabilities and everything. I think that's 3 points I would like to add.
So from the lens, we'll take it to Pranay. Pranay will bring in the logic of legacy to cloud to modernize to constantly evolving, right? And the scale of security essentially not just shifts on this lens, but also evolves drastically. But the assurance is always. How do
Sure.
you bridge that?
Yeah, so I think, as is very well put it, see, things are evolving, right? I mean, so how many have seen the IPL? Raise your hands, please. Only few. Okay, no takers of IPL because of Mumbai Indians. Okay, so how many will see the World Cup, Football World Cup? Please raise your hands. I think only few people are awake still. Okay, so do people need access to servers, to content? Yes, very much. Can we go back? Most of us see matches, etc., on mobile devices. There's a plethora of devices. In fact, I mean, if my daughter takes away the phone, I can see it on the tablet and all that. So there will be a lot of access. So there will be things at scale. We cannot really scale down, okay? But does it require security? Very much, yes. I mean, obviously, it does require security. So now how do we solve this problem, especially with the generation of AI? So Kubernetes is a beautiful thing that has happened, okay? It has made things dynamically scalable. But how do you protect the pods, the APIs, the microservices? Do we know patterns? Sure, we do know patterns. But what has changed between maybe 2 years back and now? What has changed is the surface area of attack is obviously more, because the more you deploy. But the pattern of attacks is changing at a drastic pace. Pehle humans were used to do it, find out some flaws. Now algorithms are doing it, okay? I mean, and they are doing it night and day, and they don't even get tired, okay? So if there are so many attackers, let's say there were 1,000 attackers previously, now there are 1 lakh attackers, there is going to be some problem. So to deal with that, the defenses also have to rise commensurately. And when we say that, humans will have limitations, our perimeter securities will have limitations, firewalls will have limitations. Zero trust architecture is obviously the way to go. Identity at every stage is important, right? I mean, if we go to Siddhivinayak temple, okay, people will access Siddhivinayak temple, everybody will come, but it has to be secured, right? I mean, there are zones, there are like some different zones. So there is a continuous CCTV in all the halls. Similarly, there has to be a continuous secure observation, which can only be powered by AI. So when I say that, for example, there is an API trend. I have 30,000 servers, let's say, and only in one geography, the servers keep everybody's directing, let's say, my 1/5 of the request is going to one server, one zone. So I need to monitor that. So that is going to be done by AI. So API level security, obviously identity crisis, okay? So if you have never expiring tokens, it's an issue, right? So you will have to make it a little tight, okay? So you can't have never expiring token. I am a developer. I want a never expiring token, but still I understand you can't have a never expiring token, right? Because it is creating a security problem. So we cannot solve problems of security at scale with the tools which we are solving right now. We will have to adopt AI for security, trustworthy AI. Having said that, the AI itself has to be trustworthy, okay? But for example, a swarm of drones which Iran sends, like 3,000 drones, okay? Patriot missile will hit something, cruise missile at target, and I mean, but 3,000 drones को सामने 3,000 drones ही चाहिए. I mean, you cannot say, okay, तुम 3,000 बजो मैं एक missile भेजूंगा, okay? Unless it's a nuclear war, okay? So I mean, scale का जो problem है उसको scale से ही solve कर सकते हैं. The only thing is what we need to be cautious about is whoever is in charge of solving the problem, which is the AI, that has to be trustworthy. There has to be means and mechanisms. Do I have an answer? No, I don't have an answer for that right now. That answer nobody has actually. We have to evolve that.
So this is where we come to clear understanding, right? Supply chain security has moved from just tracking where we got our softwares from to looking at how they were built, the ingredients of it, then tracking those ingredients to figure out whether something is going bad at them, to then moving at machine generated code speed and tracking changes and risk on that as well. This adheres on continuous attestation, continuous trust, and a forever anomaly monitoring regime. Looking at both agent and agent-based and agent-less runtime monitoring as scenarios. So what is next, right? From the lens of OEM, what's next in terms of this supply chain security direction?
It has to be a mixture of all the things combined. Like most of the people till now have mentioned security from a different aspect in the software supply chain world. One of the aspects that is obviously going to evolve a lot in the coming few months, years is AI-based detection. I was talking to few of the panelists earlier, and I said that AI is still in the baby steps. 12, 18 months back, we were using ChatGPT, and we were really happy with it. We were basically using a bot and asking it random questions. It was giving us some data analysis, presentations, Excel, and we were excited, really excited. In the last 12 months, just imagine where the world has come into, where now we have models like Mythos, which do vulnerability analysis at such a deep and detailed level that they cannot be opened up to the general public over there. And the world of AI will evolve a lot more going forward. But that doesn't mean the traditional security practices are no longer useful. They need to be discarded. It needs to be a mix of the traditional security practices with a lot of AI-backed detection coming into picture. And the AI-backed detection will become more and more finesse as the amount of use cases and data contextually that we will be able to do. I do believe that going forward on the AI detection side, we are going to be moving away a lot more from large language models into small contextual based language models. Models which are very specific to a set of industry practices and regulations, which will be able to do security very specific to use cases that a customer has over there. And that's where the scale of those will come into picture.
So Neeraj, as a practitioner, what is your take on this?
Sure. So I'll go one step back. So of course we can use AI based monitoring going forward in future. We have AI thankfully now. But I'll go one step back because what I believe or what we believe as a firm that we need to take care of security during the build itself. So as we know, like now the way we build software has completely changed. These are not now built anymore. These are now assembled using various components. Of course, AI is one of the components that we integrate in our softwares. So what has become very important nowadays, if you're building a software, because of this supply chain risk, you can now use SALSA framework, which takes care of your build and the source integrity. Then you can use provenance. So right from build till the entire code base goes into production, you should have end-to-end log, which tells you who built it, which pipeline was used to build this code, for which is the target environment, and artifact signing, of course, is one of the pieces in this entire security which we should use. So this is during the build itself. Then SBOM, of course, is a key component which comes into picture, and we already spoke about the matured SBOM, how it looks like. And with all these, 3-4 components, along with artifact signing will help you to ensure that your artifact which is running in the production is not tampered. But what before that? So artifact will only tell you, the signing will only tell you that it was not touched once it was into production. But you need to take care of these things during build itself. So yeah, this along with, of course, runtime, constant monitoring using AI will definitely help. So that's the future, I think, and that's the path we have taken in 361 as a firm.
Yeah, sure. So, as precisely said, there has to be a combination of the technologies. So, traditional human in loop should be there along with the AI. So, continuous attestation is needed as a core part. Over and above that, the agentless monitoring is important since the scale is vast, the applications development is going, and to monitor at large scale, this agentless monitoring has to be there. And AI is definitely there to help for the anomaly detection, and further we can have the AI in place as well for the resilience.
Pranay ji, your view on the change in terms of landscape?
Yeah,
What's
I
next?
think these are, I look at it more that all of these are pillars for this, the foundational pillars. So all three are required. Continuous attestation is required. Anomaly detection is required, and also agentic is required, and I'll tell you why. The first, continuous attestation, the example that I gave about executils, right? So unless you have a mechanism where you can continuously test till the last, it is like the airport security. Till you board the aircraft, there are checks one after the other, and maybe there are other checks also which we are not aware. Okay, where you are continuously being observed till you, because it is important. It is very obviously, one wrong package, one wrong person on the flight is a issue. We all know that, right? So continuous attestation is required, and all of this, as Neeraj rightly said, artifact signing, okay, or having something in place is one layer. So I look at it as a more of a layered approach, layered architecture towards a final zero trust architecture. Okay. Second is anomaly detection. Now, obviously, now things which are at build time, static time is one thing. Things on production at runtime is another thing, right? How many requests you are getting per second, okay? From which all geographies you are getting. See, I was at MCX. MCX typically used to have 26,000 cyber attacks per day, okay? And we used to continuously monitor which geography we are getting, and then we used to geo-block those IPs. So this is monitoring. At the same time, what is the pattern, okay? And the patterns, there may be subtle patterns also. So if AI is a helper there, it is a very good helper, because it is generally good at detecting patterns, sub-patterns, which may be an anomaly, and even one can be detected, it can save lots of cost. Third is this, so it is good for the value, actually. The anomaly detection is a very good value. The final one, which is maybe good for adoption, is agentic. Now, I come with a disclaimer that when we go for agentic, okay, it has to come at a reasonable cost. Obviously, security is something which no one can compromise with, especially in the fiscal space. But at the scale at which we want to defend, we will require more helpers, right? It can't be humans, it can't be our traditional SOCs and NOCs, okay, which can only do this, okay? They may be there, but they will also have to be AI-powered, AI-assisted. So there would be specific goal-based agents looking at only one particular thing, okay, and nothing else. And you can have maybe 1,000 different categories of these agents, okay, from trusted sources, or you build yourself, or whichever, and pilot it for some time in production in some area. and even continuously attach that also. Okay, at the end of the day, AI, wherever it is done, it has to be explainable, and we are in charge of the AI. Nobody can get away saying कि अरे ये इस कोड का प्रॉब्लम है या ये इस एजेंट ने नहीं डिटेक्ट किया. Eventually, the company which is running the business is answerable. Give an example of SEBI. SEBI is the regulator for the country. They came out with a circular in 2022, and they said that any exchange deploys anything on production, whoever be your vendor, okay, that is your problem. The business is yours, okay. So testing is your baby, and I 100% agree with that. Whichever way you develop software, whichever way you deploy software, you are doing it for a business. The business is yours, and eventually you are accountable. Whether it be AI, non-AI, it's not the point.
In the world of software supply chain, whether we were on 1.0, on 2.0, or we go to 3.0 or 4.0, the standard equation will continue to remain. You can only trust when you can verify, and you can only assure if you continuously verify, right? To this in context, we open it for the audience to ask a few questions. Anyone in the audience can raise their hand and we'll proceed with questions if any. Okay. In absence of audience questions, we'll just quickly run it to last bit that we kept, which is a rapid fire question. And the last question on that front is, what is one control, not multiple sets, one control as of today, which you feel gives you the highest degree of assurance? We'll go from left to right.
I would like to say there's something which we have already implemented. Okay, okay. Policy control is something which I majorly, yeah.
If it has to go into one word, I'll go with security as code. Security as code.
I would say zero trust policy.
I would say SBOM.
Tracking asset inventory, software inventories.
Provenance and a salsa framework. I'll go with that.
Keeping track of the lineage.
Continuous monitoring with AI-backed research.
Continuous monitoring.
AI agents employing zero trust architecture.
AI agents with zero trust. Further summarizing on this, our landscape is very fungible. While we are heavily regulated, the trust that has to be assured is of customers. While we do all of the effort, we are always operating from pieces of components from software libraries that are sometimes widely refreshed, maintained, not maintained, partially maintained, have to be outsourced to be maintained, forked internally for long-term maintenance, and the challenges continue to go on and off. Right? Replacement challenges to maintenance challenges. But every view adds the dimension of a practitioner, of a visibility, and of solving this for everyone. Thank you to the panel.